Welcome to this quantum security and defense presentation, Quantum Sensing for Earth Observation, and thank you for being a valued member of our community.
Aaron Strangfeld is a quantum engineer at the European Space Agency, ESA, where he leads the development and strategic coordination of quantum sensing technologies for Earth observation. He previously worked with Airbus, expanding their quantum sensing capabilities, and has contributed to several high-impact projects, including next-generation laser systems for quantum applications. Aaron is co-leading the working group on quantum sensing for Earth observation in GRSS IEE, holds a master's degree in physics from Humboldt-Universität zu Berlin, and earned several certificates on innovation and system engineering from MIT X-Pro.
Yes, thank you so much, Anna. It's great to see that you have assembled such an engaged community. I just wanted to keep track of it's still 56 participants, but we're good. They're still listening. I was wondering if they're caring more about the direct defense-related work.
Because we care about everything.
Yeah,
you will be surprised.
You're also interested in adjacent fields, because my focus is actually not on defense and security applications. There are other people at ESA that are more involved with that. I'm more involved with quantum sensors for exclusively peaceful purposes, especially Earth observation for science, understanding our Earth, tackling climate crises, these things. And my presentation will be structured the following way. I will give you a very high-level overview of what the European Space Agency is. And then I want to explain a bit how quantum sensing looks like to us. So how do we approach this topic? What are we doing right now? And then in the end, I have some take-home messages based on my observation of the domain itself. I already was mentioning that my work is exclusively dedicated to peaceful purposes. And there's also the Charter of ESA, where we state that the ESA is committed to peaceful exploration and use of space for the benefit of people, society, and our planet. We are also celebrating our 50-year anniversary this year. I think it's just in a few days from now, when we were founded in 1975 by the first member states. Since then, we have gathered many more member states. We are 23 since this year. We also have associate members and one long-standing cooperating state, which is Canada. So all these member states, they contribute to ESA as a space agency. So our main work focuses on shaping the industrial landscape of the member states for space applications. And this we mainly do through procurement of activities. So we define what we want to procure based on the space mission that we want to launch. And then we have industrial and academic collaborators that execute this work that we are then overseeing and guiding. And in doing so, we have a lot of application spaces and activity areas that you see here as an overview. The one that I'm concerned with is Earth observation. And that's why I'm also now continuing to talk about Earth observation and what we're doing in this domain. It's all about understanding Earth, improving lives, and fostering sustainability through space technology. And space gives us a unique opportunity, or you could say unique vantage point to look at Earth. Space is the only way where we can have a reasonably easy access to the full globe. We could call it global coverage of our observations. And we have also quick revisit time by doing so. You can imagine a satellite revolving in its orbit around Earth. It will revisit the same spot on the surface after a reasonable number of turns around. What you see on the right side is the diversity of information that we can get of Earth. These are just example images based on different frequency bands in which we observe, different altitudes where we observe. One of these images also indicates surface temperature, for example. So based on the instruments that we put on the satellites that observe the Earth, we get different information. You see, and you might know that Earth is very complex. There are a lot of dynamics and it's very hard to understand. We also recently grow more and more of an understanding that the Earth's balance, the equilibrium of Earth, might be shifting to different states, which we call a transition through tipping points in the climate. So it might be necessary that we redo our learnings and redo our science based on new dimensions of this development of the Earth system. I push this aspect of complexity to justify this image as well. You see a high number of different satellites that we have launched over the past decades being active in the Earth observation domain in ESA. What you see here, and this should be the core message of this slide, is that there are 3 branches of our missions. On the left, you see the science. It's about understanding Earth, new insights, new models about the dynamics. Then you have the Copernicus framework, which are operational missions. We have identified that there are certain measurements that we want to continuously take, incrementally becoming better in doing these measurements to have a monitoring service. And then you have the third branch, which is meteorology. This is all about weather, which we have identified already very early. This is something crucial to monitor from space to do reliable forecasts.
Watch the full presentation, plus presentations from over 70 quantum experts. Find training courses in quantum cybersecurity, quantum blockchain, and more. Simply search for Quantum Security Defense for more information.